Hello, this is Ryan with Tronics Lab. Today we're going to do a short video on pointers. The reason we're covering pointers is in future videos, which will be on Win32 programming and whatnot, they're used quite extensively, and I don't want to clutter up those videos with boring pointer tutorial type stuff. So we're going to cover it in one video, and if you need to go back, you can come back to this one and just review, and hopefully it should get you back on track. So to get started, I want to give you kind of a usage example of it, but I'm going to give it to you at the end of this video. And I don't want to just give you some silly generic example either. I want to make it applicable to future videos in Win32 programming and DLLs, just because I can. And if you're following along at home, it's helpful to get a useful example. So pointers, these three guys right here, they're pointers. This is the way to declare them with this little star. That's the star notation for declaring a pointer. You can see that we've created three different types of pointers here. Essentially, these pointers are all the same. The only difference is that the pointer itself is pointing to a different data type. So this pchar is pointing to a character. pint is going to be pointing to an integer. pw pointing to a double. You can see I've initialized these pointers to null. You do not want to leave them unknown, uninitialized. It'll have a value, some garbage value in it, and if you accidentally dereference that pointer with garbage value in it, you'll be accessing memory outside of what you want to be accessing. You'll get segmentation faults, and you could overwrite important things on your computer that you didn't plan to when you're running your program. So 3 pointers, and then we're going to output the value of the pointers. I don't want to get into why I have these casts here too long, and in this little commented out section, static cast to avoid pointer. You can read why I'm doing that in my 3-line comment here. But you can see the result of this section right here, printed out. We've printed out the value of each of our pointers. They're 0 as we initialize them, and null is defined as 0. Next, we're going to declare 3 variables. Character, an integer, and a double. We'll call them my char, my int, my double, and give them some random values. And then we'll print them out, and you can see the result below. Each of our variables, they all have the assigned value. So let's round this one. So let's get into the meat of it here. Now we're going to print out the address, our char, int, and double, by using this symbol here, the address of operator, and it'll give you the address and the printed out result here. You can see that the computer that this is being compiled on, this isn't on my computer, this is the web C++ compiler, but you can see that it's a 64-bit machine just from the length of this address here. It's got 64 bits in an address, so yeah, I can only assume it's a 64-bit computer. Each of our variables has a unique address. That's where our variable exists in memory. Now we will initialize our pointers to something more useful than null. We'll initialize each of our pointers to our variables. So we'll initialize our integer pointer to our integer variable, and likewise for char and double. And then we'll do a little print operation here. We're going to print out the value of our pointers, and the value in each of our pointers is the address of our variables. And we can see what we've done here. We've done the exact same thing as when we printed the address of our variables. We are assigning the address with the address of operator to our pointers. And you can see here our char pointer is assigned our char address of variable. So these two are the same, these two are the same, and these two are the same. Now the real interesting part is when we actually dereference a pointer. Dereferencing a pointer involves using, once again, our star notation. So you take your pointer variable and you dereference it with this star. If you were to put that into a sentence, what's happening here is you are saying, give me the value that this pointer is pointing to. Don't give me the value of the pointer. That's not what we want. We want the value that this pointer is pointing to, which is actually my char. And you'll see what happens when we print out the values of each of our pointers here. So we're going to print out the value that pchar is pointing to, which is my char, and the value in my char is t. My char is t. We assigned the pointer pchar to my char, which is that address. As you can see, we've dereferenced our pointer, which is t. And we got the same result for our other pointers, integer and double 1000 from our integer and 10,000.1 because it's rounded off. So let's look at the size of our variables. We've got all of our variables here. Our pointer to an integer, pointer to a char, and pointer to a double. The size of our pointer to an integer is 8 bytes, as you can see. The size of the address of our pointer is 8 bytes. And we know that's true because we've printed out the address before, and it is 8 bytes, 64-bit. And the third one, the not important, but interesting one, is the size of our dereferenced pointer. So what our pointer is pointing to, the size of that. So the meaning of all this is, well, our pointer is a variable that is meant to store an address. And well, on this computer, it's a 64-bit address, meaning it's 8 bytes. So in order to fit an address value into our pointer, it has to be 8 bytes wide. The address of our pointer obviously is 8 bytes because it's an address, and this computer is 64 bits, so it needs 8 bytes for that address as well. But the dereference value of our pointer to an integer, which is 4 bytes on this computer, skip ahead over here, an integer, the length of an integer is 4 bytes. Same with our char, 8 bytes for addresses, the address of our pchar, and the address stored in our pchar, 8 bytes and 8 bytes. But if you look at the dereference value of our pointer to a char, it is 1 byte because a character is 1 byte. And over here, down below, size of a char, 1 byte. Size of pdouble and the address of pw, both 8 bytes. Now, we got 8 bytes here. That is only because a double is 8 bytes wide on this computer, as seen below. Now I've printed out all the different data types. So let's put these pointers to a bit more use here. Reassign our pointer to nextchar. We've made a variable nextchar somewhere here, and we've assigned it A. Down below, pchar. Previously assigned my char to pchar. Value of my char is t. The address of my char is this. The current value in pchar is this long thing, which is the same as this other long thing. The address of my char. Dereference value of pchar is t, which is my char. Now we've gone and assigned pchar to nextchar. So let's look at nextchar. Nextchar, the value is a, and it's got a different memory here, address. And after assigning it to nextchar, it's got that memory address stored in pchar, and if we dereference pchar to give us the value of this address, which is nextchar, which is a, we get a. And that's pointers. We also have reference variables. It looks like the address of, but when you're actually creating a variable and you use the reference operator there, you're actually creating a reference variable. We'll create a reference variable, called it refchar, and we'll assign it to mychar. The purpose here of reference variables is you're not making a copy of a variable, you are just making a variable and you're giving it essentially an alias. You're giving it another name. So we've created mychar, it's a character, it's got the letter T in it. Well, we've decided to make another variable, and it's called refchar, but all refchar is mychar. It's just with a different name. It's really simple, and it's just useful later on when you're doing pointery type stuff. So I got a little happy and I made one of each, int and double reference variables. And we're going to print out the results of certain things. Checking that out, we've got char and refchar. It's got the value t. Why does it have the value t? Well, because we assigned it to mychar. It's just a reference. It's an alias for another variable. So we print out ref char, we get T. Print out my char. Printed the address, but if we printed out my char, as we do up here, it's T. But I printed out the address just to prove to you that it's not a copy of the variable. It is quite simply a reference to it. It is an alias. They have the same address, just a different name. And we've done it for each of our variables. Ref, we made a reference to my int. They have the same address, same value, different name or alias. Same with doubles. That's it. I'll link this code into the notes. If you go to this site from the link, it'll give you this code, and you can play around with it and just see what goes on when you change some values. And I just wanted to give that to you. So thanks for watching. I hope it wasn't too bad. This is my first video, so let me know what you think, and thanks for watching.